All right, this is a section on improper integrals. This is the first three forms. There is another form after this, but it looks a little different. All right, in this form, keep in mind these are always definite integrals. Remember, a definite integral is when you actually have limits on the integral sign. Right? So one of the limits in this example is infinity. So I guess it's probably too small for you to see here. But like here, in the top one, the top number is infinity. Number two, the bottom limit is a negative infinity. And in number three, it's negative infinity and positive infinity. Okay, and we'll talk about what happens with that later on. The bad news is I could not find any examples about where it's negative infinity or positive infinity that was not inverse trig. So, sorry. All right, you do need to see how it works, just so you can see how it works. But chances are good you're not gonna get that one right. All right. Anyways, so here the upper limit is positive infinity, and the first thing you're going to do is rewrite it as a limit. And when I say limit, that's what I mean, right? Limit as, and I like to use the letter B for the top one. The letter really doesn't matter. Sometimes you have to do it twice, so I keep it separate. All right, you'll see what I mean later on. All right, so limit as B goes to infinity. I have, and I rewrite it as 1. And I write B there. So instead of infinity, I have a regular number per se. Right? Dx over x. All right, when I take the integral of this rather, I'm going to get natural log of x from 1 to b. So that means limit as b goes to infinity. And by the way, you might get lazy and start dropping off these things. Once you drop it off, you have now made an error and you've lost all credit. So don't be lazy. Right? You have to keep that limit sign. So that's natural log of b minus natural log of 1. Well, we know natural log of 1 is 0. So this part is going to 0. It's not a fraction bar. That's just me emphasizing that part's going, I should write it this way. It's going to 0. Or equals 0. Not going to 0, it's equal to 0. But natural log of b, as b goes to infinity, the natural log of b goes to infinity. So this is infinity. So when that happens, we say it diverges. Right? So there's no numerical value. So that means this does not have a numerical value. This integral does not have a numerical value. And the integral diverges. Right? It's no specific number. And you might be saying, well, duh, it's going to infinity. Why would it have a number? Well, you will see that some of these will actually converge to a number. Okay, and that's example 1.